We're from the Sweet Next Club at Patrick Henry High School in San Diego, California. Our club was founded 2 years ago with the goal of exposing high school girls to different STEM fields. Since then, we have had many successful STEM professionals speak about their careers and paths to success. We have also participated in numerous activities, outreach events, and field trips. Much like the boundary breakers that have spoken to our club members, Stephanie KWOLEK broke boundaries in her respective STEM field, chemical engineering.
Instead of studying medicine, KWOLEK chose to pursue chemical research, which was uncommon for women in the mid-20th century. As part of her research, she developed Kevlar, a synthetic fiber stronger than steel, with little help from her male colleagues. Kevlar saves lives through its use in bulletproof vests, has advanced the construction industry by strengthening suspension bridges, and facilitates communication by improving long-distance ocean cables. This shows that KWOLEK's research and her invention of Kevlar has broken many boundaries in STEM fields and beyond.
For this demo, you will need shaving cream, food coloring, toothpicks, paper towels, index cards, and an object with a flat edge, such as a ruler. First, lay out a paper towel and set another one aside for later. Spray shaving cream onto the paper towel. Then, with your ruler, spread out the shaving cream to the size of a 3x5 index card. Now carefully, put a few drops of food coloring onto your shaving cream. Then, use a toothpick to create your design by dragging it through the color. When you are happy with your design, place an index card, blank side facing down, onto the shaving cream and gently press it down. After a few seconds of applying light pressure, peel up the index card and set it down on the extra paper towel that you set out before. Finally, use your ruler to scrape off the shaving cream in one swift motion. You should see your awesome design appear in your index card.
This works because of the properties of polarity. Polar molecules have an uneven distribution of positive and negative charges due to their structure, allowing them to be attracted to other polar molecules, including water. Nonpolar molecules have evenly distributed charges, causing them to repel water and polar molecules while attracting other nonpolar molecules. The differences in polarity of the three substances in our demo, food coloring, shaving cream, and paper, allows the marble design to transfer. The food coloring is primarily water and is extremely polar as a result. The index card is composed of cellulose, parts of which have similar structures to water molecules, making the card also polar. Shaving cream, on the other hand, has both polar and nonpolar components, which limits the dye's attraction to it. So, when the paper is placed on top, the dye transfers to the card because it is more attracted to the polar card than the only slightly polar cream. The properties of polarity can be fully demonstrated when water is sprinkled on a mixture of dye and cream. As you can see, the dye is attracted to the water and is therefore pulled down to the bottom of the dish with the water, making the top layer of cream white again.
Understanding polarity is extremely important to chemical engineering. For example, water-resistant materials, such as in clothing, are made from primarily nonpolar molecules, leading them to repel water droplets. Polarity is also applicable when developing chemical dispersants to clean up oil spills. As we know, water and oil don't mix because water is polar and oil is not. This makes it difficult to clean up oil spills. Chemical dispersants are like shaving cream in that they have both polar and nonpolar parts. The nonpolar parts are attracted to the oil, and the polar parts are attracted to the water, allowing the two to be separated and cleaned up easily. More specifically, the oil is cleaned up by being broken down into small enough pieces to be naturally consumed by bacteria. To this day, chemical engineers are working towards developing new chemical dispersants which have the same properties yet are less toxic to the environment.